Okay, so guys, in this video, or actually in this series, we are going to see how you can find the derivatives of the functions given to you, and also, in other words, how you can differentiate some functions given to you. So first of all, what is differentiation, or what is finding the derivatives? When we are given a function y is equal to f of x, and we know in the common daily life, we do not have things which are constant. For example, the air pressure is not constant, the stock market is not constant, so everything is changing. And to find something which is changing, we also need a system that finds the changes. The system called differentiation, which actually indicates from the word differentiate. Okay, so what happens in this differentiation thing? We just add the change which is being going on over there in the function which has been given to you. For example, this is the delta x. This can show the increment or the decrement in any function which has been given to you. It can be your stock market, it can be your mobile prices, it can be anything. It can be the number of TV shows displayed in a day. This can be anything. And this is the dependent variable. Y depends upon x, and x is the independent variable. So the independent variable is, you can say, the prices of stock market. Okay, they are independent. Now which thing is most affected by the change in the stock market? Of course, that is the GDP, that is the national income. So the dependent variable will also change if the independent variable changes. Okay, so we are also going to produce a change in the dependent variable, that is y, in this function. Now, how can we calculate this change or this differentiation which is being done in this function? So there are a couple of ways in which you can solve for the change in the function. And in this video, the first video of this series, we are going to solve using the differentiation by the first principle method, in which we are going to solve approximately 6 steps, and then you are going to know that how the change is happening over there. Okay, so this was the first step, that you have to let the function, okay, you have to make it a function, that is that you have to convert the equation into a function. Secondly, you have to produce a change in it, the change which has been given to you. Thirdly, you have to transport this y to the right hand side, fx plus delta x minus y. And after that, you have to put this value of y which was in the first step. So we're just going to put it in here, and delta y would become fx plus delta x minus f of x. What are we going to do next is the fifth step, and in the fifth step, we are going to divide delta x, and this is known as the differentiation by the first principle method, in which we are going to solve approximately 6 steps, and you are going to know the change which is being done in the function. Okay, so this is the fifth step, and this is the most important step in solving using the first principle method, that you have to divide it by delta x. Okay, and of course, if you are dividing it over here, then you have to divide it on the both sides. And after that, the last and the final step is that you have to produce a limit into it, limit delta x approaches to 0. Okay, where it shows, let me write first of all what it shows over here, fx plus delta x minus f of x and divided by delta x. Now this limit actually shows that wherever in the function delta x is given, we will put the value of delta x equal to 0. Okay, so the limit will be applied on both sides. Now these are the most and the two last important steps of solving using the method of derivatives using the first principle method. So now what will happen, you can simply write dy by dx. Okay, now remember, you can't write d before putting this limit. You have to first of all put the limit, and after that you can write dy by dx, which actually represents delta, where delta is the change, is the increment or the decrement. Okay, and the same goes over here, limit of delta x approaches to 0, and fx plus delta x minus f of x divided by delta x. Now these are the 6 steps by which you can find the increment or the decrement in a function or in any equation which is being given to you, right? Now we are going to solve a couple of different examples, some in this video, and some of those examples we are going to solve in the next video, right? So the key thing to remember over here is that differentiation or derivative is the method to find a change in a function. It is the method to find the increment or a decrement in the function. Okay, so this is the first question related to differentiation using the first principle, and the 6 important steps have been shown to you on the right side of your screen. And now, what is the first step? We have to let the function 2x square plus 1. After that, we are going to produce a change in the independent variable, that is x. Okay, x plus delta x square plus 1. And after that, we are going to also produce a change in the dependent variable, that is y. And now we are going to transport the y to the right hand side. So 2x plus delta x square plus 1 minus y. And remember, these consist of two terms, two values. So we are going to put a bracket around y so that it does not cause trouble for us. So 2x plus delta x square minus 1. Now remember, this is the one of the important steps in solving for differentiation using the first principle, that you have to simplify the function in this third step. Okay, so we are going to simplify it. First of all, you are going to open this formula, x square plus 2x dot delta x, and I'm going to open it using the a plus b whole square formula, minus 1 minus 2x square minus 1. Okay, and I just multiplied this negative sign inside the brackets. I am also going to multiply the 2 inside, so 2x square plus 4x dot delta x plus delta x square minus 1 minus 2x square minus 1. So you can see that the 1 and 1 can be cancelled, and 2x square and 2x square can also be cancelled. So what is remaining over here is 4x dot delta x plus delta x square. It cannot be simplified much further, so we are going to move towards the fifth step, and that is dividing by the delta x. Okay, so we are going to divide by delta x. The trick is that you have to simplify it until you reach the point that you can take delta x common from the given equation at this endpoint. See, if I take delta x common, what will happen? 4x plus delta x remains, and now I can simply cancel delta x from both sides. All right, so you have to simplify. Now the question arises, if you are simplifying this function in the fourth step, the question arises up till where you have to simplify it. So this is the point that you have to simplify it until you reach a point where you can take out delta x as common from the both values. So now we are going to move towards the sixth and the final step, and that is putting the limit of delta x approaches to 0, delta y by delta x, and after that limit of delta x approaches to 0. This is the function that remains after cancelling these delta x's. So 4x plus delta x, and now what I told you about limit delta x approaches to 0, wherever in this equation we have delta x, we are going to put 0 over there. So this becomes 0 and we get our derivative, that is 4x. And remember, now here we can write dy by dx. It is a rule in differentiation using the first principle that you can write d only after putting the limit, and it is actually necessary to write d after putting the limit. So this is the derivative of your function, and you can also write it in this form, that d by dx is equal to 4x. And what is the value of y? 2x squared plus 1. So we are going to put it over. All right, so guys, I have a little bit tricky problem over here, and the problem over here is that this x, this independent variable, is actually inside the root. So first of all, let's begin by making it a function, and then by doing an increment in just the independent variable and also in the dependent variable. Now we are going to move the y towards the right hand side, and 2 minus x plus delta x minus, and I'm going to use a bracket so that the negative sign does not cause problems for me. Okay, so 2 minus delta x, and now what are we going to do in this function is that I can cancel 2 if I just multiplied this negative sign inside the y function which I have been given. So 2x plus delta x minus 2 plus delta x. So you can see that 2's are cancelled over here, and I get minus x plus delta x plus root x. Okay, and now what are we going to do now? I want to show you something over here, that if you reach the point where you can't simplify further and you can't also take out delta x common, you can move towards something known as rationalization. What is rationalization? It is an understood thing that this term contains a 1 denominator below it, all right? So what are we going to do in rationalization? We are simply going to multiply and divide by the inverse of this whatever the term is given, okay? X plus. So what I did, this thing is known as the rationalization. We are going to multiply and divide by the opposite of the same, you can say the function. And remember, this negative sign will change into a positive sign, right? So what would happen next? If you see, I can combine these two equations, and this is one equation, this is one equation, this is an whole equation. So root x minus root x plus delta x, and remember there is a multiply sign, so x plus delta x, and there goes the bracket, divide by 1 times, that's pretty simple, x plus delta x. So if you see this equation right over here, this is the same equation that I copied from this previous page. So what is going on over here is that we have a minus sign and a positive sign, and this is going to become, I think it's our a, and this would be our b, this would be our a, as you know, x and x's are same. This is going to our b, as you know that root x plus delta x and root x plus delta x is the same on both sides. So if you see that I get a form of a minus b and a plus b. So what does this shows? Actually, a minus b and a plus b is a formula which is represented by a square minus b square. So I can write this form in root x square minus root x plus delta x squared, okay? And after doing this, I can cancel this square, so I get x minus x plus, actually no, I got to use this minus sign with a bracket, because minus sign is going to cause trouble for our equation. Now x minus delta x, so what is remaining over here is this minus root x. After simplifying this numerator, actually I get minus root x, and now in the denominator I have root x plus delta x. Now if you see, going toward the fifth step, I can cancel the delta x if I bring it down over here, right? And in the sixth step, if I apply the limit, what would happen? This delta x would become 0, and this can be simplified, right? So this is the point where I can't simplify further, all right? So I'm going to divide delta x and delta x. So delta x is being cancelled over here. Now I'm going to apply the limit of delta x approaches to 0 and delta y divided by delta x. So this is the limit, delta x approaches to 0, and you have to remember that there is a negative sign over here which is going to be represented by a negative 1, and in the denominator we have root x plus delta x, and what is we got a root x, delta x approaches to 0, so this becomes 0, and we got minus 1 over root x plus root x, that becomes minus 1 over 2 root x. You know that there is a 1 on by default on the left hand side of the root. So the key thing over here is that you have to simplify the equation until you reach a point where you can remove delta x from the equation and simplify further by putting on the limit, okay? So I hope that this lecture makes sense.